Okay, I am recording. All right, so this is ITS128. It's February 7th, and we are still in Chapter 4. Are we in Chapter 4? So let me share my screen. Share. I do this and do this. You can't see this at home probably. All right, I'm going to pop this dude down here, and I'm going to move this over here and put this down. And we're in ITS128. Today is February 7th. We are in the Chapter 4, Making Decisions. And does anybody remember if I finished the slides last time? Maybe not. Let me go to PC, this thaw space, Alberson, Chapter 4. Let me go to the end. Oh, list boxes. No, we have not finished list boxes. We haven't covered list boxes yet, have we? Oh, we haven't covered the switch statement either. Switch statement. Change, check to change event. I don't think we've covered that. Checkbox control, radio control. Oh, we have not. Radio buttons. Okay. Yeah, we're going to use radio buttons. Did I cover? Okay, I remember I talked about radio buttons with our assignment, but have I covered them in our slides? I did, probably not. Input validation. Oh, try parse, preventing data conversion exceptions. Okay. Okay, we did cover Booleans. Okay. Oh yeah, that's right. Dubel. Dubel. We did cover try-parse, samples of try-parse. I remember covering this. Okay, input validation. Input validation is a process of inspecting data that has been entered into a program to make sure it is valid before it is used. Okay, so, you know, there's always the problem of users either inadvertently or on purpose typing in wrong data. And so if you're writing a program where you are entering in some, like you enter in the number of hours, and if you enter in the number of hours, you can, if you're entering in an integer, for example, you have to enter in, there's only 10 valid characters that you can enter into that text box. You can enter in a bunch of them, but there are only 10 valid ones. No, you can enter in a bunch of characters just as long as they're all of those 10 valid characters. And of course, those 10 valid characters are the 0 character, the 1 character, the 2 character, all the way up to the 9 character. And anything else is not valid. If you are entering in hours that have a decimal point, you can enter in a bunch of digits, a bunch of digit characters like I just mentioned, and then you can also enter in 1 decimal point someplace in that set of characters that you enter in, and only 1. If you enter in 2, it doesn't make sense. If you enter in something other than digits, it doesn't make sense. So those are ways that you can have an invalid input. Now there's two ways of handling invalid inputs. One is by writing something called an exception handler, and then you use this particular kind of programming statement, this particular kind of C# programming statement called a try catch. And I don't think we've come to try catches yet, but it's actually easier than data validation. Okay, with input data validation, you actually anticipate the type of error, and then you write code to trap it. You can say it, trap it or catch it. So the user types in something that's wrong, your program will catch the error or trap the error or detect the error. And based on the detection of the error, you do something before it actually causes your program to bomb. If you don't do anything, if you have no input validation and you have no other mechanism of determining or catching an error by the user, then your program bombs. And in this day and age, and well, we never want our programs to bomb. So it's up to the programmer to make their programs robust enough so they don't bomb. And one way to do that is using these try-parse methods, which I mentioned before. And with the try-parse method, you are able to combine both the conversion of those digit characters into the number itself. You're able to combine that function along with a function which actually will tell you if it worked or not, or not if it worked or not, but if it will work or not. And so we use this int.tryparse method, and what that'll do is it will look into the first argument you pass it. The first argument you pass it is going to be where that string of characters is that should translate into an actual number, in this case an actual integer. You tell it where to find it, and then you also give it another variable name. In this case, the variable name is called number. It's an integer variable. You give it that variable name, and what this int try-parse method will do is first it'll look to see if the user typed in a valid a valid set of characters that can translate into an integer. And if the user did, then this will return, then this whole thing here will become true, will become a true value, which means that this if statement has a Boolean expression inside of it that evaluates to true, okay? And what this int try-parse method will also do is, if it works, it will actually do the conversion and will give you back the value in this variable name that you pass it. And in this case, it's called number. And it's an output variable, which is why the word out is here. And what that means is that the method is going to pass back out the actual value. So if the guy types in 1, 2, 3, ABC, the int try-parse method will evaluate to false, which means it won't work. And then whatever ends up getting put into number, who knows? It could be left the same as it was before, or it could be changed to 0, or whatever. It doesn't matter. You're going to ignore it anyway because it's not usable. And the if will not be taken, and it'll skip out. And you'll probably want to have an else for that if. And in the else, you'll probably display up an error message saying, "Hey, dummy, please type in some digits so I can convert this properly to an integer." Or maybe you'll be more polite than that. So input validation is the process of inspecting data that has been entered into a program to make sure that it is valid before it is used. The try-parse methods check if the user enters the data, but does not check the integrity of the data. So, for example, in a payroll program, we might validate the number of hours worked by doing something like this, where if the hours is greater than 0 or less than 168, then we do something with it. In case you're wondering, 168 is the number of hours in a month, a number of hours in a working month. That's a accounting number that we remember. Or it's 168 or 172 it's the number I always use. But my first programming job I had was writing Fortran programs for a business administrator at a company, and we calculated payroll amounts all the time, and that's the number we used. And for example, in this case, we're testing to see the input should be a test score between 0 and 100, and you know, not outside that range. So this is input validation, but it's not input validation that a try-parse would use. A try-parse would test to see if the hours typed in was actually, you know, a number and not some letters, or you know, whereas whereas with input validation we would go further and actually test like the range or something. Okay, so now let's go to and we will do more with input validation as we go further with the class. Right now, though, we're going to switch to radio buttons and checkboxes. And as we know, radio buttons are where the user can select one choice out of several choices. In this example, we are checking, you know, if our favorite sport, let's say we're talking about favorite sports, and the reason they call them radio buttons, I might have told you this already before, but the reason they're called radio buttons is because back in the old days, car radios had these push buttons to change the station, and back before they were mechanical. And in fact, they were mechanical, and you'd push the button, and there was a string inside. The tuner was this thing called a variable capacitor, and it was actually this dial. And if you look inside, there were actually these metal things that would get, you know, close and open, and so you would tune to a station, and then you would set the buttons, and then the buttons were such that you could push one button down. Oh, it's kind of like on a blender. You know, blender, you can push one button down, and then you push another button, and the first button pops up again. Is that how blenders work?
The old ones, I think.
Yeah, okay.
It's now just like clickable.
Oh, now it's just electric, okay. Well, my blender still's got those push buttons. But so I guess we could call them blender buttons. But we call them radio buttons for that, and that's where the name comes from. So only one. You only have one. Whereas with checkboxes, you can have more than one. And so in this case, the sport, you know, you're limited to one choice. Whereas with this checkbox example, pizza toppings, you could have more than one. Right. And with radio buttons, you aren't supposed to be able to have none. But you know, when the program starts up, you may have none. But then as soon as you press one, then you cannot unpress. You can't unpress the button. Whereas with checkboxes, you can unpress a checkbox by clicking it again, and it should uncheck. So the .NET framework provides radio buttons, and now the thing is you know, you can have lots of radio buttons on the form. If you just have a bunch of radio buttons on the form and you do nothing else, then they all act like the same radio, or they all act like the same blender, okay? But you can group them. So and the way you group them is you put this group box control, which is what this outer thing is here, and then all the radio buttons you put inside the group box control act as one radio or one blender. And so you could have many group boxes on a form, and you can stick radio buttons in there, and then they will be their separate little radio button thingers there. And so there's with these, and both with checkboxes and radio buttons, you've got a text field which contains what we see here in the text, and we have a checked. Okay, these are both properties. We have a checked property, and what that checked property does is it'll say whether or not the control is checked or not. So it'll be true if it's checked. It'll be false if it's not checked. Both of these are read-write, which means you can actually through program control, change a radio button to checked or not checked. And same with checkboxes. You can test them like this, where we're testing to see if something is checked or not. You can also check them like test like this. It's the same. This is the same as this. It's just that it's a different way of writing it. You might think this is more clear, but actually this is perfectly fine because this thing will evaluate to a true or false, just like this will evaluate to a true or false. Checkboxes are the same. They operate the same way. There is a checked changed event where, okay, this is an event where if something happens to the radio button or something happens to the checkbox, in other words, if it's checked or unchecked, then this checked change event triggers. And then once the checked changed event triggers, then you can go look at it and see if it is now true or false. See if it is now true or if it is now false. And then you can do something based on that. A switch statement. This is like a different kind of decision structure. It's like if else if. If else if is actually a little bit more flexible. But if you can use a switch statement, you might find it's more convenient because it can be more compact. It's kind of less code. It can appear more clear to the person that's writing the code or the person that's trying to read your code. So a switch statement, the structure of a switch statement is like this, where you have this thing up here called switch. It's not, that's obviously spelled incorrectly. I think they do that on purpose. It's not switch. It's actually switch. Okay? Switch. Don't write switch. You'll get a little red squiggly underneath it. Won't know what you mean. Okay, so you have switch, and then you have this expression, and this expression does not evaluate to true or false. Well, actually could, but it doesn't evaluate to true or false. It evaluates to something. Maybe some digits, or I mean, maybe a number, an integer number. It may be an integer number. It may be a Boolean value. It may be a string. It's got to be something exact and not something that gets messed up if you're converting from base 2 or base 10 or whatever, all these other ways that things can get messed up if you're dealing with floating point numbers or you're dealing with numbers with decimal points. They can get messed up inside in a computer because we humans like to see things in base 10 and computers like to work with stuff in base 2. And when you convert from base 2 to base 10, back to base 2, back to base 10, you can lose precision if you're dealing with decimal numbers. And later on, we will write some programs that will actually demonstrate this. In fact, this is exactly why we have two variable types that represent numbers with decimal points. We have double type variables and we have decimal type variables. And sometimes it's okay to use double variables. In fact, sometimes you need to use double variables because the range of a double variable is much wider than the range of a decimal variable. But a decimal variable can be more exact. A decimal variable actually does not have the problem of converting between base 10 and base 2 because numbers internally are actually represented like base 10 numbers and so. But anyway, that's detail that you don't need to know. You don't need to ever know that unless you take an assembly language programming class, which you may be able to do someday here at KCC. But
they have assembly programming class?
There will be.
There will be.
So yeah, probably in the fall.
Hardware.
It's as close to hardware development as you can get without actually pulling out your soldering iron and starting to wire up stuff. But yeah, we will be writing programs in the machine language of the microprocessor. So we'll be learning about how a microprocessor works and how it interacts with the memory and that kind of stuff.
And that's IT.
Yeah, that'll be ITS128 AL, and it should be approved for fall because I'm writing it, so it'll be my course. And you only have to have ITS. You only have to have this class to take it. You learn. You're going to learn stuff in this class, and it's all the level of programming that you'll need to know, and then you can take that class, and we'll actually learn how the microprocessor implements this kind of stuff. So it'll be a very interesting, very enlightening class, I hope. So anyway, that's so in. But anyway, so let's get back to this stitch statement here. So you have an expression here, and it's some expression. It's gonna, you evaluate. It's gonna be like an integer, or it's gonna be like a string, or it could be true or false. And then you have these case statements here. Case, and then this is some value that. So let's say you have an expression here. You know, stitch a plus b, and let's say up above here you've got a equals 1 and b equals 2. Okay, so up above here you have a equals 1, b equals 2, and then and let's say this expression is a plus b. So the test expression evaluates to the value 3, right? A plus 1 plus 2 is 3, and then so you can have case 1 colon, and then down here you have case 2 colon, then you have case 3 colon, case 4 colon, you know, or all the different possibilities that you want to account for. And then at the very end of these cases you have a default, and that covers all the rest of the cases. So inside each of these case blocks you can have a bunch of statements, and then at the end of the statements you got to have this break. Okay, and then you start with the next case value, and then you have a bunch of statements, and at the end of that you have to have a break, and so on, and so you do the case, and then it jumps down to the end. So as long as you have a break after each one of these set of statements, you will only do one case value, or you'll do the default. If you don't have a default, then it'll just do one of the case values. If it's not any of the case values, it won't do anything. It'll just skip out. So each case is an individual subsection containing one or more statements followed by a break statement. The default section is optional and is designed for a situation that this test expression will not match with any of the cases. So this is what a flowchart would look like for. So let's say you have this variable called month, and month can either be, you know, the January, February, March, April, or let's say you're only going to go to January, February, March. So then case 1 would be, this is wrong. This is wrong. All right, just these slides are just BS, man. So I'm going to take this and I'm going to move it over here. Whatever. I'll put it down over here. And I'm going to put some new stuffs here. Put this letter here. What am I? Okay. Switch. Something like this. Switch. Month. No, I'm going to do something like, first I'm going to do month equals January. Switch month. Just because it's being stupid and putting in capital, I'm going to do that. And then you do like this, dot, dot, case. Oh, in this case, no, this is right, because this is an integer. This is not the character set. Okay, so this is month is going to be, okay, I'm going to change this a little bit. No, I guess this is correct, because month is going to be a value 1, 2, or 3. I see. I'm sorry. I was the idiot. Okay, so month is going to be a value 1, 2, or 3, and if it's 1, it's going to display out January. If month value is 2, it's going to display out February, and if month value is 3, it's going to display out March. Otherwise, it's going to display out error invalid month. So forget what I was going to do here. So month has got to be an integer, and so this is the case statement. Now this word break here, you have to have that statement there, because otherwise it's not going to break out and go down to here. It's just going to keep on going. So if you were to leave this break out, if you were not to have the break and this word break here, and you were just to have case 1 colon message box show January 2, case 2 message box show February, and then break. Okay, if you did that, then if the case is 1, it's going to display both this one and this one. So once it finds the case, then it just executes all the statements down the line until it hits a break. And once it hits a break, then it breaks out. It's not gonna. There's nothing to execute with case 2. Case 2 is just kind of like an entry point. So these cases are like entry points. So if the month is 1, then it enters here. If the month is 2, it enters here. If the month is 3, it enters here. If it's not any of those, it's going to enter here. And then it's just going to keep on executing down. So you can think of these cases as entry points. And if you don't have a break, it's just going to keep on going down. So that's why you need the break. Now, you can take advantage of that, because maybe you want to have something where you always want to do case 2, but you might also want to do case 1 before you do case 2. You see, so in that case, you wouldn't need the break. You wouldn't put the break there. And let's talk about list boxes later, because we have two more days here. So I'll save those for next time. What I did want to show you is first of all, I want to show you how you make. Let's see. Did I put one of my assignments here? What did I put for assignment 4? Did I upload something? Oh, I didn't, did I? All right. So all right, I started to make this before. Did I save it? I didn't save it either, did I? I did not. Okay, let me start at Visual Studio. Visual Studio. VISUAL, there it is. Sign in. All right, so let me start a new project here. New project. Windows form. Browse. I'm going to put it down in my thaw. Whatever. Well, I don't know why they call it that. I don't know why they call it that. We're still in chapter 3, aren't we? this chapter is fine. And I'm gonna name it color mixer. And let me do a toolbox, general. Let me pin this dude. And we're gonna have, okay, so you remember I told you if we just have 6 radio buttons on here, 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, and we got some buttons here, 1, 2.
I find it easier to make a group box and then make 3 buttons and then copy paste it.
That
It just resets the text and the.
That is exactly how you should do it. What I'm doing here is I'm going to show you what happens when you don't do a group box first. And then I'm going to see if I can put a group box around it. I'm not sure how that'll work. I think, but definitely make the group box, put the radio buttons inside, and then once that's done, you make a copy, and then name them and make a copy of that, and then you're done. That's a judicious
Group box control,
and then pop those buggers inside, and then name them. Just like because you're gonna make a duplicate one exactly like it anyway, right? So why not make one? And then you copy the whole thing, make a duplicate of the whole thing.
the control names are not going to be copied, right? Or will they?
No. If you make a duplicate, it changes it to group box 1, or it changes it to a generic name. It's not going to copy the name.
Oh, that's good.
Okay, so I'm going to try. So I'm going to do this to show you that once this is running, you see, bunk, bunk, bunk. See that it makes it those other ones over there not work, yeah. And that's not what you want. So now I'm going to see if it will work to just put a group box around it. Let's see if that works. It's a container. It should work. I click on that, and then I think I can go like this. Okay, I've got a group box around it. Now I'm going to run it, and I can go bump. Ah, yes. Ah, yes. Okay, so there's the set inside the group box, and then there's the set outside the group box. And somebody asked last time how you can make it so when you bring it up, the radio buttons are always empty, or they're all shut off. And the trouble is if you try to do it now by, wait a second, let me close this. All right. Let me name these things. It's tab stop equals false. Okay, so you can go like this. If you want a method to execute immediately when the program starts, the event, this is all event driven. So there's got to be an event. There's got to be an event. And what's the event that happens immediately when the program starts? Well, that event is that this form loads. The form loads. That's the form load event handler. And to get at that method, you can double click any place on the form that's not a control. So if we double click out here, here it is, the form load event handler. And we not only have to do radio button 1 dot checked equals false. We have to do these a bunch of times, all of these. Radio button 2, we're going to have to name these later. Equals false. you have to do these, 6 times. 3, 3, 4, 5, 6. But you also have to do this above it. Radio button 1 dot tab stop equals false. And you do that 6 times. Now, I told you I was going to do.
So you just Control C, Control V.
Yes, yeah, that's what I'm doing here. 4, 5, 6. And now I told you I was going to tell you how I found that out. Let me see if I can. Okay, it's formulating the Google question. C#. How do I make it so all radio buttons are clear when starting? Is that do you think that'll work? That Google question will work. How to uncheck radio buttons that form load? Well, that's this one. This is Microsoft.
Yeah.
And blah 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 blah. Oh, it does. You can set tab stop property of both radio buttons. Okay, so yeah, you set the tab stop property of all the buttons to false. I like Stack Overflow. I just really like Stack Overflow because, and this one says.
The Facebook program, or is that GitHub?
Huh?
So Stack Overflow is like a Q&A program, right?
I think so. I think it's great. Somewhere along he says, okay, they say it's a bug, blah, blah, blah. Anyway, the one I found yesterday, there was a bunch of people with answers that weren't right, and then finally this guy says, I did it by putting tab stop equals false for every one of them. Don't ask me why it works. So that's what I did. So yeah, so that works. And now when we start it up, it's see, they're all off. All right, so I wanted to show you that, and we have 2 more class periods. So the other thing I want to show you before the class is over, I think we might end the class early today. I know all of you are here, so I'm going to give all of you a break today by letting the class out early. I wanted to show you. I kind of finished the program when I wanted to solve the tab stop problem, or the tabs where tab stop is a solution. I just got carried away with myself, and I just finished up the program here. So I wanted to show you how mine operates, and then you can sort of use this as a model. And we're online. We're recording this, so we can. So this is what my form looks like. This is what I made my form look like. I made it 12-point font. I have a mix button. I have a reset button, and I have an exit button like it asks. And then I have this color word down here, which is going to say what the color is, just in case you are unfortunate enough, although a very large percentage of the population has some sort of color disability. So I never like to. The second programming, or when I was an engineer back in the 80s, I had a friend who used to get so angry with people because they would use color to distinguish in their documentation and everything, and he would just get so mad, so angry with us, because he was really colorblind. He was really bad, and he just would and so since then, so I was an early advocate of not using color to distinguish, and I always speak up when people are just, well, that's the blue one here is this, and the green one here is this, and my friend used to say, God, traffic lights are so bad. It's like blue and green. It's like I'm driving along and boom, this blue light comes out of nowhere. It's green. The green light comes out of nowhere, and I almost miss lights that way. But Anyway, so let's run this, see what it looks like. I'll run it. And so I do red. So I made it so if you just click one color, it just does that color. And then you can reset it. And of course, the directions are if you use two colors, it's going to do that color. But if you do red, blue, and you mix it, it turns to purple. Red, yellow, you mix it, it turns to whatever color this is. Must be orange.
We have to look at, use the color wheel as the reference for this project.
No, you just use. No, you're making it more complicated than it is. You just got to do what it says. So there's only three combinations: red, blue, red, yellow, blue, yellow. Those are the only combinations there are. It's just that, you know, it's just that sometimes you do the red first, sometimes you do the first one first, the second one second. So if you list out all the combinations, you'll see that there's just these three, and just set them that way. I don't know if they're correct. They probably are correct, because otherwise, you know, why would they be correct? But another way to do this would be, you know, these are not the colors. This is mixing. This is mixing paint, but when you're doing light, it's a different set. It's like red, blue, green, or something. RGB, red, green, blue. Yeah, and that's a different way of combining. I think that's light or something. I'm not quite sure what the difference is, but anyway. So yeah, this is yellow, and then you can do blue mix red mix yellow red mix. Reset. Oh, yeah. The word is down here. It's red. Okay. And then you might want to know what color is this background. What color is this background? Well, it's not gray. It's let me see if I can make the color here. No, let's close this. Let me go back to my other one. Do I still have my other one? It's in the thaw space. Did I just close it up without doing anything? I hope I saved it. I So yeah, that's the one other thing you got to know, and that's how to make this color. So let me just do, so I'm just going to make this, oh, I didn't mean to do that. I'm going to take this one, I'm going to say red. I'm just going to say, the color, where's this text? Oh, see, it says control. The color is control. It's actually system color dot control or something. So let me show you that. Oh, here, red. I'm gonna do that, and then I'm gonna throw in another reset button down here just to have a reset. Now I'm gonna make that text be reset, and I'm gonna call it. I'll just call it button 3. Okay, so oh, and I'm gonna say when. Okay, so I'm gonna say, and this is gonna be the mix. All right, so and I'll just make it when you click on this red and click mix, it turns the whole thing red. So let me double click on that event handler, and I'm going to say if radio button number 1 dot checked, you want to set the background color. This, you got to use this color. Oh, back color. This back color equals color dot red, something like that. Okay, fine, does that. And then if you clear, okay, so it's going to set the whole thing red. And you do reset. You want it to do this back color equals system color, system colors, maybe system colors dot control. There we go. That's what it is. So that's how you get back to that system color. So, oh, and let's just try this and see. So I'm going to do red. Ooh, I didn't even type mix. Oh well. Reset. Ah, see, now it's back to the system color. Why did it? Oh, because I put the event handler when I actually click the checkbox, or when I actually click the radio button. So that so next Tuesday I'm going to talk about text boxes, and then I'm going to start taking this program and I'm going to replace the radio buttons with text boxes. No, not text boxes, list boxes. So I'm going to talk about list boxes, and list boxes and check boxes and radio buttons. They all kind of do the same thing. They're all for the same thing, but it's for a different thing. With list boxes, you can set the list box so you can only select one at a time, like a set of radio buttons, or you can set the list box so you can select more than one at a time, and that's like checkboxes. So I will mess around with that next time. But in this case, the reason it turned red as soon as I checked the radio button is because I actually put it in the checked changed radio button event handler rather than the mix radio button or mix button, you know, click event handler. I hope that made sense. All right. Are there any questions? You over there? Questions? What did you? No. Oh no, you don't have a question. Okay. Well, how about, okay. Sis, you stop. You're making too much noise. And everybody can hear you. Look, nobody. You can't hear anybody else, but we can hear you and you. Anyway. All right. So I guess I'll call it quits for today. Put this. I have you guys over here. So I will. So I've given you some last-minute hints that you need to finish your assignment, I think. And next time we'll start doing some extra stuff. Oh, there's a chat. Someone. These really should be cyan, magenta, and yellow.
Someone just sent you.
Yeah, these. So Zoom can can send me a chat. All right. I'm gonna have to look that up because there's two different two different sets of these three colors, and you mix them up and you get other colors. But I think you're right.
Actually, it's for this one. It's CMYK.
K is black.
Yes. Say that again. Is that JK talking?
Both, yeah. K would be black.
Okay. K is black. Okay. All right.
Oh, CMYK. I see.
CMYK. You cannot, or because we're doing, because that's a different kind of mixing, not the other kind of mixing. All right, I'm gonna have to I'll study that for a little while maybe, and unless one of you guys want to do that, or. All right, very good. Thank you, JK. All right, so I will leave it here, and thank you everybody. It's nice engaging class today, and I'll see you on Tuesday. Thanks for watching.